Plant designed for production of ethylene oxide.
Background and operation of ethylene oxide production. What is ethylene oxide? Ethylene oxide is a flammable and a toxic colorless gas. Its chemical structure is of a cyclic ether with a sweet odor at room temperature. It is soluble in water with high vapor pressure, and in liquid form it is less dense than water, but when in vapor form it is denser than air. How its production develops. The Olden method was developed in 1914 to 1937, that is the chlorohydrin process, where ethylene chlorohydrin is converted to ethylene oxide by reaction with calcium oxide. The process is very inefficient as most of the chlorine used was lost as calcium chloride. The modern method developed in 1931 and used until now is direct vapor phase oxidation process, where the ethylene is oxidized to ethylene oxide by reaction with oxygen in air and silver is used as catalyst. The process flow is indicated later in the Visio flow, but the steps are as follows. Air is collected and compressed at high pressure, 26.5 bar, by compressors. Next, air and ethylene gases are mixed and heated, 240 degrees Celsius, by heat exchangers. Then, air and ethylene react to form ethylene oxide, water, carbon dioxide in reactor with silver as catalyst. The product are then sent to separation column to recycle the unreacted reactants to second reactor, and the unreacted gases are recycled back to the reactor. Lastly, ethylene oxide is separated from carbon dioxide and water as final product at 10 bar and 98 degrees Celsius. Reaction scheme. The method used is direct oxidation and has three reactions that can take place. The first reaction and second reaction are favorable as they produce the product needed, being ethylene oxide, but the third reaction consumes ethylene oxide to produce waste carbon dioxide and water. The reactants and catalyst enter the reactor here, for the reaction to take place. The reaction kinetics for this process doesn't use the rate constant, but uses a function of pressure and temperature. Process flow diagram, PFD, shows the process flow from collection of reactants to the reactor, separation, recycle, and finally the product stream and waste are obtained. Process parameters and reactor design. The reactor used for this process is a packed bed reactor, as the oxidative process can take place more efficiently and quickly in this kind of reactor. In the reactor, the temperature and pressures at the inlet and outlet are kept constant by using a coolant, at 240 degrees Celsius and 26.5 bar. Ethylene and oxygen are consumed and ethylene oxide, carbon dioxide and water are formed. This means all three reaction occurred in the reactor. Reaction 1 happens the fastest, hence the high amount of water and ethylene oxide compared to carbon dioxide in the outlet stream. And lastly, these are the references used for this entire project, listed in APA format. Thank you for watching.